Hello everyone, my name is Yoshi Suhara. In this part, we will talk about evaluation metrics and benchmarks that are commonly used for opinion summarization research. Evaluation metrics can be categorized into two approaches, automatic evaluation and human evaluation. Automatic evaluation is based on manually annotated resources or external classifiers. It is convenient because once collecting annotations or preparing external classifiers, we can run the same evaluation for newly developed models for comparisons. However, automatic evaluation has a certain limitation. The evaluation heavily relies on annotations or model used for evaluation. That's why it is common to conduct human evaluation in addition to automatic evaluation. Let's start with automatic evaluation. For reference-based evaluation, we need gold standard information to compute metrics. The most standard way is to ask annotators to read reviews and write gold standard reference summaries. As summary writing is a subjective task, we usually create multiple reference summaries for each entity for robust evaluation. So, opinion summarization benchmarks consist of pairs of input reviews and corresponding reference summaries. Here's a list of publicly available benchmarks with the number of annotated entities, input reviews, and reference summaries. Those benchmarks are created on top of customer reviews in e-commerce, dining, and travel domains. Recent benchmarks, such as Space and Amazon, collect more reference summaries for a larger number of input reviews. Now we are ready to calculate evaluation metrics using pairs of input reviews and corresponding reference summaries. The most common evaluation metric in opinion summarization is ROUGE, which is also the de facto standard metric for other text summarization tasks. ROUGE metrics are calculated based on the overlap between generated summaries and reference summaries. ROUGE-1, ROUGE-2, and ROUGE-L are commonly used for opinion summarization. ROUGE stands for Recall-Oriented Understudy for Distinct Evaluation. And ROUGE-N originally defined only recall, but F1 values are commonly used for opinion summarization. Let us share concrete examples to explain how to calculate those metrics. Let's start with ROUGE-1 calculation. Suppose we have a summarizer which creates a summary. The hotel is in a great location. And we have a reference summary. The hotel location is great in a dataset. ROUGE-1 is based on Unigram matching. That means we check if each token in the generated summary appears in the reference summary. In this example, the hotel is great location. Those 5 tokens appear in the reference summary. The precision can be calculated by the number of matched unigrams divided by the total unigrams in the generated summary. We have 7 unigrams in the generated summary, so the precision can be calculated by dividing 5 by 7. For the recall, we consider the total number of unigrams in the reference summary instead. In this case, 5 out of 5 unigrams in the reference summary appears in the generated summary, so the recall is 1. Finally, by taking the harmonic mean of the precision and recall values, we can calculate the ROUGE-1 F1 score for this generated summary. ROUGE-2 calculates scores based on bigram matching. In this example, only one bigram, the hotel, appears in both generated and reference summaries. So the precision, recall, and F1 values should look like this. ROUGE-L is based on the longest common subsequence between a generate summary and a reference summary. In this example, the hotel is great is the longest common subsequence, and thus depreciation, recall, and F1 value should be like this. This is intuitive, but ROUGE has certain limitations. One limitation is that ROUGE scores are based on token level matching. For example, the words great and excellent both show strong positive meanings, but are considered different tokens by ROUGE. Look at the two generated summaries and one reference summary in the slide. Those sentences look semantically similar, but ROUGE score are low because only two unigrams, the and is, are matched. A natural question is whether we can take into account semantic similarity between words, so we can consider the word excellent is a better choice than the word bad for reference summaries that contains the word great. That's the motivation behind BERT score, recently proposed evaluation metric based on pre-trained language model. Instead of relying on token level matching, BERT score uses contextual embeddings or pairwise similarity calculation between words. It also considers word alignment by using the maximum similarity. Please note that the score depends on the choice of the pre-trained language model for contextual embedding calculation. We need to use the same model for direct comparisons. Let's move on to the other automatic evaluation metric, which is classification-based evaluation. Classification-based evaluation calculates consistency between the generate summary and the input reviews using external classifier. For example, sentiment classification and aspect category classification models are commonly used. By comparing predicted ratings, we can see if generate summaries and input reviews have the same level of sentiment polarity. The matching accuracy of ratings can be used for evaluation. Here's a summary and pros and cons of automatic evaluation. We presented two approaches, reference-based evaluation and classification-based evaluation. Reference-based evaluation calculates matching metrics based on reference summaries. Classification-based evaluation uses external classifiers such as aspect-based sentiment analysis models to calculate the consistency between generate summaries and the input reviews. The biggest benefit is that we can rely on the evaluation as many times as we want. However, automatic evaluation relies on the quality of reference summaries and classifiers. It may not necessarily assess the overall quality of generate summaries. That's why human evaluation is also used for opinion summarization. Let's talk about how we conduct human evaluation. In human evaluation, we ask human annotators to assess specific performance characteristics by showing generate summaries and the original input reviews. Here's a list of commonly used criteria. Informativeness, fluency, conciseness, coherence, redundancy are often used for human evaluation. How should we ask annotators to report those metrics? Multiple rating scale is a natural option, but it has limitations. First, rating scales may not be discriminating. An annotator might give 5 to all methods. Second, different annotators may use scale differently. In this example, the other annotator gives significantly different scores to the same generated summaries, mainly because this annotator has a different standard for judgments. Pairwise comparisons could be an option as it doesn't have those issues. However, it requires and choose 2 judgments in total, which may not be easy to annotate. That's why an effective annotation schema called best-worst scaling is often used for human evaluation. With best-worst scaling, the annotator is asked to choose the best and worst methods. In this example, the 2 annotations can be converted into 5 pairwise judgments. Here's a human evaluation task example using best-worst scaling. In this example, each annotator is asked to report the best and worst methods with respect to informativeness, coherence, and non-redundancy by looking at the original reviews and summaries generated by different methods. Those annotations can be converted into scores, so we can compare multiple methods in a single table. There are several options to convert best-worst scaling annotations into scores. A simple method is subtracting the percentage of times method X was selected as worst from the percentage of the times method X was selected as best. With this way, the score for the unanimously best method becomes 100, and that for the unanimously worst method becomes -100. Look at the example. We have 4 sets of annotations. Then we can calculate the percentage of times chosen as the best and worst for each method, which can be converted into scores. Here's a summary and pros and cons of human evaluation. Human evaluation asks annotators to manually evaluate multiple criteria, such as informativeness, fluency, coherence, and redundancy. For effective annotation, best-worst scaling is often used for human evaluation. With human evaluation, we can conduct more detailed and target assessment than automatic evaluation. On the other hand, human evaluation relies on annotators' subjective judgments, and thus task design and annotator recruitment are essential. Also, it is very expensive. We have to conduct human evaluation again whenever we have a new method. Lastly, error analysis and qualitative analysis help us understand the strengths and weaknesses of different opinion summarization models. This example is taken from the plans and paper. By highlighting sentences that describe specific aspects, we can understand the proposed solution creates a summary that focuses on 3 specific topics: atmosphere, staff, and beers, while the other methods create summaries that also contain other topics. This kind of qualitative analysis is very helpful to understand if a proposed solution implements a certain types of functionality. This section has covered different approaches for evaluation: automatic evaluation, human evaluation, and qualitative analysis. It is common and essential for opinion summarization research to conduct multiple evaluation approaches to evaluate solutions in a comprehensive manner.